All right, it's 11:05. Hi, everybody. My name is Nelson Milian, and I'll be talking to you today about driving K through 12 innovation with open source tools for the future. Just to kind of start this off, can everybody hear me fine? Sounds good. Okay. All right. I would like for this to be kind of like a discussion-based type of presentation. I hope to not be just presenting to you for an hour. So it'd be nice to hear from everybody if possible. If you can't, that's fine. But it'd be nice to hear from everybody. All right, so I guess I'll begin. Let me share the screen. All right, so my name is Nelson, and I'll be your host today. I'm from Miami, and kind of been living here most of my entire life. And the person you see next to me is Willie. He's on the chat as well. He's my business partner. We started an organization called 01 about 2014, and it was really to teach children technology, but in a way where we were trying to bring kind of the newest technologies to children that were just, kindergarten, first grade, second grade. That has to do with 3D printing, virtual reality, electronics, teaching them how to solder, teaching them how to just build things, right? And it kind of mirrors a little bit about how I educated myself and with schooling as well. But really what drove me into technology was just kind of a curiosity into how do I make something? How do I build this technology? How do I use it to solve a problem? When I was very little, I remember days where I was just creating. I had a bunch of big box of Legos, and every Saturday I would kind of have this box. I would throw it all over the floor and then start building something and create some good stories. And then from there, just pack it all away and restart the next Saturday or Sunday whenever I had time to play. So the idea behind the kind of the education part is, how do we use technology, and especially open source technology, to teach children how to use technology, build technology, use it to solve problems, etc. This is a picture of our office. We closed it in 2019, right before I guess the pandemic hit. But most of the stuff that was here was built by us and at the Fab Lab Moonlighter, which I'm currently in right now. Any questions so far? No? Okay. I will continue. So a lot of the stuff that we kind of base our education on, at least Willie and I at 01, was the idea behind what Seymour Papert was doing. If you don't know who Seymour Papert is, he co-founded the MIT Artificial Intelligence Lab, the MIT Media Lab. If you've ever used the Lego Mindstorms, he had his hands in that, and the Logo programming language. I don't know if anybody's ever used the Logo programming language. Let me see, like a raise of hands. Participants. Well, if you've ever used, let's say, Scratch or Snap or Turtle in Python, the idea has been, how can I use a computer, right, to really have the kids construct and build inside of this thing so that they can kind of enhance their learning, right? And Seymour Papert believed that. Seymour Papert believed that we do our best learning when we kind of have a problem. And the projects I'm about to show you don't don't necessarily have, let's say, a problem, but they were kind of like an internal problem for me, which is I didn't know how these things were built, and I'm not the best designer, but there are people all around the world that have designed these great open source projects, and they're available to build, but you do need, you know, a little bit of skill. So some of the projects that I want to showcase are projects that I've started with middle school students here in Miami, high school students here in Miami, and some of them are currently being completed right now. And I hope to then show that to the students where they can build the projects themselves and learn about the, you know, the major concepts behind them. I'll start with the first one. Oh, I forgot about this. So if you don't know what open source is, just a quick description. Open source projects, products and initiatives embrace and celebrate the principles of open exchange, collaborative participation, rapid prototyping, transparency, meritocracy, and community-oriented development. Basically, the idea is, you know, there's a lot of great people out on the internet, and I hope to hopefully become one of them, where our designs or their designs, their ideas are put out there for other people to use and be remixed. Usually began in really the software development side, but kind of progressed into a more general term. What I'll be focusing on today is not the, I guess, software development side, but more of the, I guess, open source hardware that has been developed. One of the projects that I started with was the OpenRC F1 car, and it was an interesting project to start with. I initially built it for myself, and it was such a fun project to build and to see kind of like, you know, you start off with some 3D printed files, and, you know, there's very little documentation, but there was a video that the creator had made. You start with this simple thing, or not simple thing, it's kind of, let's say it's an intermediate project, but you start with it, and as you're building it, you're learning about the different aspects that the designer went into to building and designing the cars. You also find things that don't work, and you kind of have to, you know, improvise on some of the designs, decisions that the designer made. This car took, I would say, about 20 to 30 hours, you know, for printing, and it uses multiple materials. I started off with, I don't know if anybody knows what PLA is, or the material for PLA, but we started off with PLA and went and moved on to PETG because one day I decided to leave the car in my car, and due to the Miami heat, it decided to start warping and bending in all different places. So just by different accidents that happen, you know, you have to kind of say, okay, what happened here? How did it break? And, you know, how do we fix it so that we can, you know, get to the goal that we want? Let's see, this was, so I did this project with one middle schooler back in 2019 at the beginning of the school year, and the students took pretty much the entire 2 quarters, which is a semester from August to January, to build. The things that the student was responsible for was downloading the files, inputting the files into a 3D printing program, kind of like Cura, which I'll go over in a bit. Learning how to tweak the 3D printer so that if a print did fail, he would have to go in and redo the prints. There was multiple times where the actual prints for the parts would come off the bed, and so he would have to go back and fix it. And mind you, I was only there for about an hour a day, and so the student had to kind of take it upon himself to go and fix all these issues. And if he couldn't, he would come to me and then we would fix it together. I think there's something in the chat. Which printer did you use with PETG? That's from Peter Perez. So the printer that we were using is the Ender 5 from Creality. Usually you can start off anything that prints with PLA you can print with PETG. Bed can use a little bit of higher temperature, and the nozzle itself, usually when we print it, PLA will print it at like 200 to 210. PETG, I'll print from like 210 to 220, 230, depending on kind of like the material. We usually do some test prints before I set a temperature for each roll. Did that help, Peter? Okay. Any other questions as I keep going? You use it, yeah, Ender 3. I use the, there's another project I'm about to share that I use the Ender 3 for, but Ender 3 is a great product that you can use to get started, very cost effective, and yeah, all around pretty good printer. I'll go over it a little bit once I talk about the hardware. So here's, so this is a few pictures of what was created. This is not the one that we created last year. I recently had a camp where I had 2 middle school students. Each of them was building one of these at a time. If you plan to ever build one of these RC cars, I would definitely take some time because a lot of things tend to mess up. A lot of the prints tend to mess up sometimes. Yeah, thank you, Willie. That's the link for the RC car if you want to build it. A lot of the stuff that went into building this is, you need your plastic. You're going to need a few different screws. If you know what an M3 screw set is, M3 size by, let's say 8 millimeters, 10 millimeters, 5, and I think 15. You're going to need a battery. You're going to need kind of a transmitter, a receiver, and you will need some soldering skills. If you don't have that, then I recommend practicing with some simple wires before you get started on this project. What we had to do for this project was we had to cut the battery wires and then wire it to the motor controller with, you can kind of see the plugs. They're like gray and yellow. They're called the XT60 plugs. You don't have to use those. You can use whatever plugs you want, but these are the ones that they recommended, and we went with it. Any questions on this project before I move to the next one? Okay, no questions. I'll move on to the next one. So actually, before I move on to the next one, so one of the things that I like about this project, especially for the middle school students, is it's definitely doable with them. It took around 15 hours with the 2 middle school students, and that was just me bouncing between both of them, helping them out. The fields, do you print the tires? The wheels? Yeah, okay. So the rims themselves are 3D printed, and the tires are as well 3D printed, yes. We use a special material. We use a special material called TPU to print them out. You do need a more specialized printer for that, and I can recommend a printer, the Prusa, if you have it, or if you don't have it, something with a direct drive. Yeah, the Prusa MK3S. Willie and I have one. I used it to print these purple tires, but I've done it also on the Dreamer. We have a Dreamer from FlashForge, and I was able to print those. Oh, nice. I haven't done silicon yet, so I would love to try that out. Maybe later you can recommend me some videos or some learning tutorials that I can go through. Yeah, so one thing that happens with these tires is that since they're more plastic, they definitely don't have a lot of grip. And so Tom from Moonlighter, let me see if I can put the video here. Tom from Moonlighter recommended Plastidip. It's kind of like a spray-on rubber, and it worked pretty well, but it tends to come off really fast. So we gave it 3 coats, and it lasted maybe about an hour before most of the rubber came off. The front tires are still pretty good, but the back tires just eats away at it. So in the project, they do have recommendations for buying rubber tires, but they're from Japan and they're like $15 each, I think, and it just wasn't worth spending that much money on the tires. Yeah, Scott, I've done Ninja Flex. The thing with like doing it on the Ender 3 that I've seen is that because it's kind of the extruder is a little bit far away from the heat block, it tends to get clogged or gets to get pushed too hard. So yeah, so I recommend more like a direct drive where the where the extruder and the heater are basically right next to each other, and it can push through the kind of soft and rubbery material. At least that's from my experience so far. Mapping a bike tube cut size. I could try it, yeah. I mean, Byron, what would you recommend to kind of, I guess, hold the tire onto the 3D printed wheel? About snapping a bike tube cut. Or do you mean like putting just the actual tire of the bike tube onto the rim itself? Bike tube on the wheel. Okay, I'll try that out for the next one that I build. Thank you for the suggestion. Bike tube on. Okay. All right, let me go back and. Hey. Oh. Okay, I'll just mute it for now. Where'd you go, Abe? All right, let me continue with the presentation. Share screen. So, really like this project. Let me see if actually, here, I can show it to you here. Oh, there goes the battery. Let's turn it on really quick. Comes with a little power switch. Turns it on. Where's my controller? I use this controller, the FS GT3B. This is the transmitter and the receiver together. It's around $50 and can be used for different projects. So you can kind of see the wheel part. And then pretty fast. I haven't been able to take it full speed because the traction isn't there yet. So I'm afraid I'm just gonna slam into something and it's just gonna explode. All right, next one. Next, share screen. So I don't know if you've ever seen this project before, but it's called the donkey car. We didn't build the bottom part, but we 3D printed the top part. This project was a little bit more difficult, and did it with high school students, and one of the things that I had to really, help him out with was he had no experience with the Raspberry Pi, and he had a little bit of experience with 3D printing because I had him as a middle school student, but the Raspberry Pi was something he had never experienced, and so a lot of the time, most of the time was spent explaining to him, how to access into the Raspberry Pi, how to use the command prompts, how to talk to the software that the donkey car was using so that it could drive itself. The documentation is very well done, and I would recommend that if you want to start building your own little self-driving car, this is a very, very good project. One of the things that you don't have to understand that much of artificial intelligence if you can follow most of the directions, because the software mostly handles everything for you. Let me see. The process was basically getting in all the parts. The high school students put it all together. When it got to the Raspberry Pi part, I helped him out. He did the training himself. What we did was we built I don't have pictures because this ended right. We were still in the process of doing this as the pandemic hit, but what we did was we built a circular track with white tape in the building on the third floor, where most people wouldn't disturb it. And the first thing he did was just try to get it running. And after that, he was able to connect to the artificial intelligence and then start training it. And the training took about 10 minutes of just driving in a circle. From that part, then I had to use my laptop to actually train the artificial intelligence. And to my surprise and to his surprise, it actually worked. I hadn't messed with this project yet, so when we both started the project, we were kind of just learning as we were going, and it was a huge success. We were in the process of making left and right turns to see if the artificial intelligence could work with that, but we weren't able to finish because all the schools closed. So again, skills for this is if you know how to use the Raspberry Pi and you already have a good skill with RC cars, this is definitely one of those projects where you can start to introduce artificial intelligence. And it's very cost effective. I think it cost us maybe, what was it, like, I think it was like $100 for the car, and probably about $150 to $200 to build this little car, because you need a battery. I used kind of like one of those power bricks, USB power bricks to power the Raspberry Pi. And then it comes with its own, what was it, NiCad, I think it was like a 7.4 volt battery to go with. Any questions about this project? Go to the chat really quick. No questions? Okay. This is another one that I'm building right now, just to kind of get more projects going. The idea is to have a repertoire of different 3D printed open source projects that the kids can get their hands on, start building for themselves. And if they want to make any modifications, they can pull up the 3D model themselves and start changing things. What I got to right now was just printing the frame out. And when I ordered the parts for the motor, the parts that came in had the wrong size, and so I haven't been able to finish it yet. But again, the idea is to have these different projects as kind of like a learning platform because to say, I want to build a tank. I want to build a car. I want to build an airplane. This is one project that I'm working on right now. This one's a little bit more advanced. I'm using, and I'll kind of provide or Willie can provide the link. This project's a little bit more difficult because they give you two options for printing. You can use regular PLA, and then there's lightweight PLA. If you've never heard of lightweight PLA, it's basically a PLA that has kind of like a gas inside that makes it foam up as it comes out. So as you're printing, it starts to weigh less than what a regular PLA plastic would be. Let me see. Let me get the pictures out. Pictures. Stop sharing this. Let's see. Open this one. Photos. Let me share. Okay. So hopefully everybody's able to see. I guess the picture's not loading very well. Let me see if I can do it the other way. Oh. I don't know why the quality of the pictures. I'll still share it now. I don't know if you're able to see kind of here, but let's make this a little bigger and move this out of the way. View, extra large icons. Okay, so top to left, this is the frame for the UAV. Basically, it's using a lightweight PLA, as I explained, and it's not a very easy material to print on. It tends to foam a lot and tends to over extrude. And I spent most of the time just trying to clean it up due to just the mess that it makes. Another thing is, since it's so lightweight, it's kind of very fragile. So I made the mistake of stacking them together to store it as I was printing the other stuff. And I placed a book on top because I forgot the box was under, and it crushed a little bit of the parts. So it's definitely not an easy material to work with, but it should make the plane a lot lighter. Let's see if I can open up this one, the kind of the picture here. Where's this last picture? All right, Windows 10 does not like to open iOS HEIC pictures. So this is the best that I can do right now. Let's see if I can blow it up even further. Share. Yeah, this is, as you can tell, like on the backside, you know, the image quality is a little bad. You can kind of see how rough it is. Now, I had to glue a lot with this project, and the idea behind this is I hope to teach the principles of flight with it as they're building it. But yeah, it's not an easy project. I will say that. Okay, let me move on to the next one. Share. So this is kind of what I have in the future for building more projects. Some of these are not, some of these are just printing machines that I can show the different concepts, like the gearbox or the jet turbine. And some of these are more practical, like building the micro drone, or I had a request from a middle school student to learn how to build a boat. The boat kind of has the same idea. You need a motor controller, radio transmitter, learning how to solder, etc. There's another one here that I didn't put a picture of, and it's the open RC truggy. It's kind of the same thing as the RC car, but off-road. And then open PCR. Open PCR is a toolbox for, I think it's duplicating DNA. Let's see, or Willie, are you going to put the link on the bottom, or should I? Let's see. Open PCR. Oh, okay, you got it. Cool. So yeah, if you're into bio or biology, I'm not an expert at it, but I thought this was a cool project that I hope to build with hopefully a chemistry teacher, a biology teacher in high school to provide more tools that the students can use. Let me go back to the, okay, Anne posted something. Oh, thank you. Cool. Let me bookmark this myself. Yeah, Willie, I got to install the HEVC thing for Windows 10. Maybe I can do it after. All right, let me continue with the presentation. Where are you? Uh-oh. Oh, here we go. Presentation, share screen. Share. All right, so I put a list of tools here that are open source and that I use a lot, and I know that Willie uses a lot because we both teach the same thing. From the left side, programming. If you've never used Git, it's a great way of storing your code. And GitHub, even though it's owned by Microsoft, a lot of open source projects are stored there. Another alternative is GitLab, which is open source, and you can actually download their software from GitLab. And yeah, it's a great way of storing your code. Then VS Code, I mostly use VS Code. It's from Microsoft. It is open source as well, and it's a great IDE, or integrated development environment for programming. You can do IoT projects. You can do all sorts of different programming languages. You can even write documentation inside of it. So if you've never used it, same thing with Atom. I highly recommend it, and it's free and open to use. If you've worked on IoT projects, you probably already have the Arduino IDE installed. And if you work in Python, the first thing that it installs is Python idle, which is kind of like the interactive development tool for Python. Jupyter Lab is a web-based development tool. So it's used a lot in writing science papers and kind of exploratory data analysis. I use it. I'm planning to use it with my middle school students, at least 8th grade, to do a little bit of data analysis. Mu Editor and Thani, they're great if you have like an ESP8266 or a microbit. They're great for programming those tools. I see something in the chat. How about Jupyter for Python instead of? Oh yeah, definitely. I like Jupyter better, but if some people start off with just the Python idle, and then gradually move on to something different. I usually install Jupyter with Conda, and it's a pretty simple tool to get started with. And link it here in the chat. Conda. Yeah, PyCharm's also awesome from JetBrains. I just put the kind of like the open source. I don't know. I don't remember if PyCharm is really open source or not. I didn't do the research for that part. Another one that we use, and it's not open source, I don't think so, but Willie and I use it a lot. It's called REPL, REPL.IT, and it's online web-based tool. So if you got a Chromebook, let's see, yeah, thanks, Willie. REPL.it, it's a great tool. You can work with multiple programming languages. It has even Python built in with Turtle. You can do JavaScript, CSS, HTML. You can program in C, C++, and a whole myriad of different programming languages. So we use it as well for remote learning. So it's definitely a great tool, even though it's not. I don't think it's open source. I don't think they have their source code up. But yeah, the PyCharm is free, so it's also another great tool that you can use. Let me go back to someone want to unmute themselves? All right. Okay. Go back to the presentation. Is that share? For pair programming, honestly, I think VS Code has one that you can use, but it's still based off a service. REPL.IT, REPL, the one that we posted on the chat. Honestly, that's been at least for teaching children, it's been the best because you can just Zoom with them, and then on REPL.it you can do a multiplayer. I posted some questions in the Q&A. Is it better for me to post them here in the chat? I don't think I have access to the Q&A, so Abe, I haven't seen any questions. But yeah, to answer, what was it? For the pair programming question, I use REPL with Zoom or any other, chat application that you want to use, and they're multiplayer. So, because the multiplayer, you can see exactly what the other person is doing, and plenty of times, the student and I, we will bounce ideas back and forth between each other, and I can highlight, I can highlight a certain line of code or multiple lines of code, and the highlight will actually show up on the student's computer as well. So for pair programming, I really love REPL, and I highly recommend it. But I think VS Code does also offer a pair programming plugin. I'm just not sure what service they're using to kind of connect it together. And then Abe, whenever you're ready with the questions, just throw them over here. For 3D modeling, everybody can see this. For 3D modeling, I've been using FreeCAD. It's Fusion. If you've used Fusion 360, it's very similar. It definitely has, I think, a lot more different tools that you can use, but it's not as refined as Fusion 360, and the documentation, tutorials and all that stuff isn't, there aren't as many resources, just like Fusion 360, or let's say you want to design a Rhino, or if you can afford, I guess, was it SolidWorks, then FreeCAD is a very, very good tool. I used it to repair my roller blades. All right, see in the chat. Okay. Yeah, I've seen that. Let's see the Open Scratch for OpenSCAD. Abe, I'm very inspired with your open source projects. Are there opportunities to collaborate with you virtually on these? I just want to make it clear that I did not, Abe, I didn't design these. I found these on Thingiverse, and I was able to kind of put them together to use them as teaching tools for students. But definitely, if you want to collaborate on different things, I'm more than open to doing that. Let's see, enable and Varan. I hope I'm pronouncing your name right. There is a I don't know if you've seen it, but Python. There is a Python version of kind of like an OpenSCAD where you can program. You can program it instead of using the OpenSCAD language. You can use Python to program in it. It's 11:45. Let me hurry up. Blender, another great tool. Very versatile if you want to do video work, but I've seen some people using it for part design, definitely using it for movies and regular 3D models. Cura 3D is, I think, as standard as it gets for most people in terms of if you're going to be doing 3D, if you need a slicing software for your 3D printer, Cura 3D will work with most of all the 3D printing machines out there. Prusa Slicer is for Prusa, so the MK3S. Yes, yeah, solid Python. Prusa Slicer is a very, very good tool if you have a Prusa printer. I think that they're trying to make it more open. I know that they have an Ender 3 profile, but I haven't taken the time really to get into it. But for when we print with the Prusa printer, the MK3S, that's what we use. Most of the time I'm using either Cura. I also bought, or we bought, Simplify 3D. Cura 3D and Simplify 3D and Prusa Slicer. I kind of bounce between the three of them because sometimes, you know, depending on the settings, you know, you'll sometimes see two printed lines very separated from each other, and then in the other slicer, they're tight. And I try to bounce between the three different ones depending on what I'm printing and how it comes out after it's been sliced. In terms of design, these are all open source tools that we've used. Blender again, Inkscape. Inkscape is a pretty decent Illustrator open source version. You can definitely do some nice SVG with it. It's not as, it doesn't have as many features as Illustrator, but it can definitely do the job. I even remember them having a plugin for making gears. So, and I believe you can, I'm not sure, but I think you can modify it with Python. Krita, another open source tool, it's great. It's a good drawing tool. So if you need to sketch something out, like an idea, Krita is great. Piskel, I know that, I remember seeing it on GitHub. It's a great tool for, we use it for little kids. It's a great approximation for, let's say, Photoshop. You know, it has a brush tool, has a selection tools, color tools. The kids can even animate things. So we mostly, at least I mostly use it for kids between 1st grade and 5th grade. And then we move them on to something a little bit, you know, with more features. GIMP is another great tool if you need something that's similar to Photoshop or Corel Draw. It's open source and it works pretty well. OpenShot is a video sequencing software. So it's similar to kind of like a Premiere from Adobe, open source, and it works pretty well. Especially, I've used it to make with the students, let's see, music videos where they shot different videos. They spliced the videos together in a non-linear way, and then added music to it to kind of bring it together. It's not as featureful as well, but you know, it works. Some of the tools, or some of the hardware tools that I used, soldering iron, wire stripper. Let's see, Varen Spot Micro AI. What's that? Oh, okay, yeah, that looks interesting. Thank you for sharing. I've seen a few of these, but I haven't yet attempted to do it, but this one looks the best that I've seen so far. So thank you for the link. I go back to the share, present, make sure that you can see this, share. So these are some of the tools that we use to build soldering irons, soldering some solder, wire strippers, different cutters. We have here 1, 2, 3. I guess I can kind of show you. So there's one behind me here, 2 over there. This one right here is the Creality CR10S. Upgrading it towards the back over there. That's the FlashForge Dreamer, where I've been doing most of the TPU stuff, and there's some down on the bottom there that we've used that are old but can still do the job of printing. Go back to the share. Filament materials, usually have all these on hand: PLA, PETG, the lightweight PLA for the airplane, ABS. ABS is good for some parts where if you want, if you need pretty good precision and then you're able to kind of do some post-processing on it, ABS is great. TPU is the more rubbery material. I've been using cyanoacrylate glue, which is basically super glue, and I used it with where's the, let me stop the share here. So got these from Amazon, but cyanoacrylate super glue, and then this is kind of like a speeding agent for the glue. Now, this don't get too fast with this, because this is really fast. I thought it'd be like maybe a minute. No, it's like literally seconds before this thing hardened. And so the first time I used it, I basically, where is this? Okay. So this is part of the, here, maybe this is better. You can kind of actually see the material here. You see how I kind of like the kind of overflowing here. But anyways, the first time I did this, I didn't think it'd dry out fast, and by the time I slid it together, it was like 90% offset. I couldn't even move it, and the only way to fix it was to break it, and so I had to throw it away and restart. And even on this one, you can kind of see that it's a little off, and I'm gonna have to reprint it because again, and this was even without the activator. The glue dried so fast that I couldn't move it after that. So if you're doing this project and you're gluing things together, that's definitely something to look out for. Let me go back to sharing. Kind of finish up here. Batteries, multiple types of batteries. In this case, the one that we're using, or at least the one that I'm using here, is LiPo battery, 7.4 volts. Works pretty well, and you're going to definitely need a charger for it. I'm using, really quick, so using this balance charger. I can't find the cable, but basically it comes with a connector and allows you to connect to multiple different types of batteries and charge it. It was like around $50. Definitely a good tool to have in your tool set if you're deciding to build these type of projects. What else? Microcontrollers, not this one. I pretty much have on stock with me always a Raspberry Pi, Arduino, or I guess the AT Mega 328, and the ESP8266 and the ESP32, and the microbit. Those are, if you want to do any type of fast prototyping, those are usually I think the best tools to go with, and they're very cost effective. You can probably get an Arduino clone for about $2 to $3 if you order from China. Servos and radio transmitters. There's a servo in here. Probably can't see it. Probably can't see it now. There's a servo in here. You can buy a pack of them for like $10, and they work pretty well. All right, last part. Let me share this part. Share. Sourcing could be an issue depending on where you go and what you need. I usually go to McMaster to get all the screws, nuts, pretty much anything I need for fastening things together. McMaster usually has an abundant amount of it and at a good price. SparkFun, Adafruit, I believe they actually make a lot of their projects here in the United States, so you can order from them. AliExpress, GearBest, and Banggood are in China, but they have really, really good products at a very affordable price. So if you're looking at buying class sets and a lot of, basically a lot of parts, I basically go with them because they usually have everything that I need. And then Amazon, I don't recommend Amazon because most people just get it from AliExpress. They buy them in bulk, and then they put them back into Amazon and sell it at a profit. So if you can wait, I would recommend just going directly to where they're making it. If not, if you're in a rush, Amazon is usually a good tool to use. Yeah, Banggood is awesome. GearBest, another great place. And last thing, lessons I learned. Documentation is not always the best, and you kind of have to improvise. And I think that's part of the learning process, right? Especially with the kids, it's like, hey, this didn't work out. How do we fix it, or how do we make it better, or how can we improve upon this? I had a problem where I sourced the wrong parts, and have extra parts now, but that's more like attention to detail. And the part that it hurts is your pocket. So this one I'm trying to minimize as much as possible. When you're 3D printing parts, there's definitely going to be a lot of broken parts, especially if you print them in the wrong orientation or use the wrong materials. But that's the part about at least 3D printing is, you have the opportunity to just kind of reprint it again, or print it differently, or use a different material. Hopefully, as metal 3D printers start to come down in price, I hope to get access to that and not have to worry so much about, broken fasteners or broken little parts that can be made in metal 3D printer or CNC'd out on like one of those little micro CNC milling machines. I talked about this glue hardening faster than you realize. It's a thing. Got my finger stuck and everything. Even my gloves got stuck. So it's a good way of making sure that doesn't happen again. And then again, understanding the materials you use. I wasn't really paying attention to PLA and the heat that it can actually take before it starts to bend and lose its form. And by having to experience that, I had to go back and learn more about what kind of materials we're actually using. And that led me down to like, okay, well, maybe the axle needs, instead of printing it in PLA, I can do it in PETG. Or hey, maybe this 3D printer, I can use it to print nylon with carbon fiber. But I know that maybe our 3D printer doesn't do that. Good, affordable for EDU 3D printers. It depends on your level of, I think, expertise and how much you want to fidget with things. Yes, as Aaron says, if you have the patience, the Ender 3 is very affordable and it works for the most part. You then have to get into the habit of making sure that your bed is aligned correctly. If not, you're going to have a lot of failed prints. But I think that's part of the learning process. And so if you do have the patience, yeah, Teaching Tech is a very good, I watch him as well. He has a lot of good videos on upgrading your 3D printer, or what is a 3D printer, what are the best materials, how to upgrade it, etc. I even used one of his videos to upgrade the Ender 3. So yeah, Carolyn, it really depends on, you know, how much you want to mess with things. If you want something that just always works and I don't, want to worry about it, the Prusa MK3S is really, really good. You still you have to build it. It's around, I think, like $800 to $900, but it's a high-end machine, and it takes care of most of the parts that you're gonna have to mess with, especially when you have to level the bed. But the Ender 3 is like $200, so you can get four printers for one Prusa. So it just really depends on, again, what your level of expertise is, how much time do you want to spend fidgeting with things, and in the long run, once you get everything working and you have the skill for it, it's pretty much all the same, because once you have the bed leveled pretty well, it kind of doesn't fail unless something gets misaligned. And since you already have the skill with learning how to fix it, then it's pretty simple to fix. Any other questions? Because I know we're at 12 o'clock. No more questions. All right, thank you, everybody. I'm gonna put my email in the chat if you want to reach out to me, collaborate in some way. Would love to, if you teach students or work with children, would love to collaborate, connect our classes together, or even just, if you're an expert and, you love to, talk and kind of dispense some knowledge, we can Zoom you in, and, you can talk